Awesome. Very good morning to everybody. So here we'll start with our second exercise in Geomagic Design X Go. So for this particular exercise, we'll be focusing on alignment of a scan to its local coordinate system. So I'm going to go here and you can go ahead and import this particular file 1_machined.stl. So I'm initially keeping these units in millimeters and I'm saying import only. So now we have imported these points and we can click on this particular mesh and go to properties and see its bounding box dimensions. It's stated as 64.57 mm by 111.26 mm by 134.2702 mm. So that looks good. And if I want to change the color of this particular mesh, I can go here. I can select the mesh in this particular model tree, and I can go here in properties, and where it says materials, you would see 3 dots. So once you click these 3 dots, you can choose the color as needed. So if you want to add a yellow color, you can say yellow, and you can say OK, and the color of the part will update automatically. So contrary to the previous case, we see that the body has come in with its front, top, and right planes. And if we do Alt 1, or in other words, go to the front view, we can see that this is not exactly the front view. This is how the front view looks in its current alignment. This is the left side view, and this is the top view. This definitely does not look like the body is aligned. So this is a very common issue that comes with respect to scan data. So we have to align this part to its part coordinate system and then proceed with our reverse engineering process. So to start with, you can start by hiding the front, top, and right planes. So you can see where my cursor is, and you can hide the front plane, the top plane, and then also the right plane. So here we have this simple lever looking structure. It's a machined part, and we can see that there are some base planes. There is a cylindrical body here, and there's another flat machined area here. So to start with, we have to use some of the features. We have to make some of the features from the scan data and use it for adding our alignments. So we can start by using the Smart Selector tool here. You see where my cursor is, and you can select this particular area. So if you wanted to extract the mid plane of this particular body, you can select these 2 areas, and you can directly go here into plane and say find a mid plane. Or you can also select area 1, and then you can go to the model tab, and in the plane tool you can extract a best fit plane. So here I'm extracting a best fit plane across all these points. It looks good, and I can say OK. I have plane 1 extracted. Now I'm going to do the same process here. I'm going to select these faces, and we do another best fit plane, and we extract another plane. So here we have plane 1 and plane 2. Now if we want to find the average plane of these 2, we can go into the plane tool again, and in method you can go and select average. So you can click on average, and then you can see that the software asks you for the entities. So you can select plane 1, and then you can click plane 2. So right away the software shows you a preview in orange. So the 2 selected planes, plane 1 and plane 2, are shown in the turquoise color, and in between here we have the average plane, and you can say OK. So here we have plane 3, which is the average plane. You can hide plane 1 and plane 2 at this stage. Now we have one direction over here. Now let us say we have another machined face in this particular direction. And if you want to extract a plane, it's very simple. You can select this area, hold Shift on your keyboard, and select this particular area. Then after you have made your selections, you can go into the Model tab where my cursor is and go to Plane. And the option is already in Best Fit and Extract. So you can take a preview and we can see that it has made a best fit plane. And at this stage, you can say Accept, and then you can come out of the plane tool. So here we have planes 3 and 4. And before we do anything, we can also check if these planes are orthogonal. So to do that, you can go here on Menu, and then you would see an option called Measure. And you would see some options like measure distance, measure angle, measure radius, etc. So you can choose measure angle, and there would be a few options here. So you could keep it on auto. You don't need to change it. Or if you want to change it, you can change it to 2 planes. Then you can click on plane 3 and you can click on plane 4. And you can see that it measures the angle to be 90 degrees, which means that these are 2 perpendicular planes, and you can use them to perform your alignments. So if needed, you can also add this additional plane here, or you can offset this particular plane and find the center. It depends on however you want to perform your alignments. So say in fact you want the center of this particular circle here to be your origin, then you can of course go to plane and offset this plane. So you can say go plane, you can say pick point and normal axis, and we want to offset this plane to this particular point. So you can choose that plane and pick a point here and drop it like that. So now we have another plane, plane 5. And you can come here, right click on plane 5 and select a cross section. So I'm offsetting it slightly down so that I get this circle clearly. And you can say OK. And at this stage, we have this circle. So if you double click on this circle, you can also find the center point of that particular circle. Now that you have that center point attached to that circle, you can try making another plane. Let us say a plane in this side. So I'm going to go and best fit a plane here again. And that is plane 6. And I can come and check my orthogonality. So I can go to Menu, Measure, and say Measure Angle between, say, this plane 6 and this plane 5. And we can see that it's also 90 degrees. And if the angles are 90 degrees or something close to 90 degrees, it means that we can use them for alignment. Okay. So now we have made these planes. So we have this plane here, plane 3, which we can rename as, let us say, symmetry plane. And we have this particular sketch, and we have this other plane. So we can rename this as, say, back plane. You don't need to rename it, but I'm renaming it so that it's easier for us to recognize. Sorry, symmetry has 2 M's, so I'm adding it here. Okay. Now, to transform this whole scan body to its updated coordinate system, there is a dedicated tab for this called Alignment. As you can see here, there's the Alignment tab. So if you click on the Alignment tab, there would be one option called Interactive Alignment. So this is a very easy 3-to-1 type of an alignment. So you can click on that Interactive Alignment tab, and it will open up this widget. Now you can say go to next stage, and you'll see that the screen sort of splits into two. The second half of the screen is not essentially needed, so you can expand this particular side. And here you can change the radio button from 3-2-1 style to XYZ style. These are both different styles. And we have three markers here: position, x-axis, y-axis, and z-axis. So you also see a coordinate system triad that comes up here. So we are basically going to match the axes of the triads, which is what you see here as position means origin, x, y, z axis, to the features that we made. It could be sketches, planes, vectors. All these candidates can be used for performing the alignment. So if I wanted to move the origin to this particular center point, I can click here on position, and I could come here and select the center. And as you can see, the triad moved its origin point to face that particular center. Now, if you want the z-axis to be matched with this particular plane, you can say click on z-axis, and you can select the symmetry plane. Now you'll see that the z-axis and the normal of the symmetry plane are aligned with respect to each other. And you can flip the directions by clicking this flip button. It would flip it 180 degrees on the opposite direction. So we chose an origin point and we chose a z-axis. Now we need one more plane to lock either the x or the y. So if you want the x-axis to be locked with the back plane, you can click here on x-axis and then hover and choose the back plane. And if you want to change the direction, you can say flip here, and the direction would update accordingly. So here we have aligned the body with the z-plane, the origin, and the x-axis. And after that, you can say OK. So now we see that the body has come in this particular shape. And if I do the front view, you can see that the body is aligned to its part coordinate system. I'm going to flip through the views. So Alt-1 is front view, Alt-2 is the other side, Alt-3, Alt-4, 5, 6, and 7. So here we have updated the alignment, and once that is performed, you can use and select all the planes and sketches that you made. You can right-click from your model tree and hit delete. And you can say delete all items. And you also have some measurements that you can hide if needed, or you can select them from the model tree and delete them appropriately. And at this stage, you can show your front, top, and right planes, and also your origin. So you'll see that your origin is sitting on that circle, and here the top face is this particular plane that you see, the top plane. So if you go to the top view here, it's like looking from the top. It's aligned perfectly and it's aligned very well. If you look at the front view, it's like looking from the front. Likewise, if you go to the side view, it's like looking from the side. So this part is now perfectly aligned to its part coordinate system. And one advantage is that now you can begin using these standard views and standard planes like the front, top, and right plane. And you can begin making your body using these standard planes which you just constructed. So here we have this particular body that we are going to reverse engineer. So you can go to this line selector tool, hover on the front plane, and select a mesh sketch. Now this is going to give you this particular shape or profile. You can look at the trace of the particular object, and if it looks good, you can use that straight away to perform your mesh sketch. I'm so sorry. So here we have this particular view, so you can hide your mesh here, and we can begin our tracing process. As you can see, we are already in the sketch tool, so I can go ahead, select my line tool, and I can best fit and trace my lines. So I'm hovering over and I'm double clicking to best fit my lines like that. And if needed, you can trim across these particular features. So you can say corner trim here, corner trim, corner trim. You can select these features, click line 1 and 2, click line 1, then click line 2, and go on and on and on. So here we are coming and we are making these trimming features, and you can also drag and extend these lines if needed. So if you wanted to drag it, you can feel free to drag it. You can add constraints, so you can make these two lines collinear, which means they lie on the same line. You can make these lines parallel. You can make these two lines parallel. It's all adding constraints. So you can click on line 1, hold control on your keyboard and double click on line 2 and make it parallel. Like that. It's a very simplistic process that we covered in the previous section. Likewise, if you wanted to make these two lines perpendicular, you can click on line 1, hold control and double click and make it perpendicular. So all these options are very much possible. And once you have a closed sketch without any disjoint ends, you can come out and you can see that we have this particular basic shape made. Now you can of course come over here and either select and make a best fit, or you can go to the plane tool and say offset this plane. So choose the pick point and normal axis method and choose this particular location. Now likewise, pick the front plane here and pick a point here and make that offset plane like that. You can also do it in between if needed. So here you can go into the model tab and go to extrude, and you can select this sketch, and in direction 1 you can extrude up to surface and select plane 1. Now you can see that it's making that complete extrude. Now to extrude in the opposite direction to this side, you can hit the check mark here in opposite direction, and you can say extrude up to surface and you can check plane 2. So here it's going to make this block type of a structure, and you can say okay. So here we have the first part of this shape made, and you can check for the accuracy analyzer by clicking on this particular toggle where you see my cursor, and you'll see that wherever we have created the features, it's pretty green on both sides. Now once you are done with it, you can hide this particular CAD body, and you can hide the other planes that you had made, and we can perform a similar process. So here you can go to the plane tool, you can offset a plane again. This is a good amount of practice, so you can say pick point and normal axis, and you can pick the front plane, place a point on this side so that we get that parallel plane. You can say okay. You can do the same process again. keep it in the same pick point and normal axis method, you can pick point plane, the front plane, and this particular point. So here, as you can see, we are using only the base planes that we made. All the planes that we made are coming from the offset planes. So at this stage, you can go to plane 3, right click and say make a mesh sketch. And as expected, the preview is not very nice. So you can extend it out a bit like this, and you can say okay. So here you might see that there is this complete solid that you need to chop off, and here you have a particular trace. Now in a case like this, you can see that there is this edge here which needs to match. So one option that you can do is go to line and best fit align. So here we have best fitted this particular line, and what you can do is you can say convert entities, and you can select this particular edge. Now when you convert that entity and project it onto this perpendicular plane, is going to provide you with this particular point. So you can drag this line and place it on top of that particular point. Now you can also convert this particular edge and say okay. Now this edge is coming from the CAD, so you can double click here and fit a line, and now you can add a constraint and make these lines parallel. You can also convert this particular entity here, and you can drag this line out so that it touches this particular point. So as of now, we are just seeing the convert entities tool and how we can use the entities from the particular CAD face and use it to make our particular sketch. So once we're done here, we can trim these two together. And if you don't need this, you can also convert it as a construction line. I'm going to hide my mesh, and you can right click on this convert entities and say make it a construction line. Now you can use the resize tool and you can extend these lines. And if the software does not permit that, you can make another horizontal line, since this is just going to be another cutout, and make a sketch like that. So now here we have made this particular shape, and we can say extrude, and here note that you can give an extrude and use a cut option. So when you do the cut option, you'll observe that it is cutting exactly at these points without leaving any other lines. So we'll look into this on the other side as well. So here I have my mesh, I hide my solid, I took this particular plane, so I can say make a mesh sketch. So here we come onto this side, offset it so that we get a good preview. And I can do this by moving this blue arrow, and I drop it here. Now I can show my mesh, and I can see that there are these edges that are created. So I can go to convert entities and convert this particular edge like that. And when I convert that, it would provide me with that particular point over there. And in this particular case, you can also convert this particular edge and this particular edge and say okay. And following that, you can make a closed sketch. So I'm going to close this sketch out, and I'm going to make closed profile for doing my extruded cut. And I can always use the power trim tool and chop off the excess sections that I have, like that. And once I have this section, I can say extrude. We need to extrude in the opposite direction, so I can use this flip direction, and I can say cut. So this is going to provide me with a very nice cut, and as you can see, I don't have any excessive lines present in any of these features. This is a very nice and clean cut, and as you can see, very easily we have made use of the convert entities features and made the cutouts. Now we are left with this particular portion, so I can use the base plane here itself, and I can make a sketch on this particular face. So you can select the face of the solid, and you can offset it so that you see this outer circle. And once you get the outer circle, you can of course do a best fitting and create a circle, and you can move it and place the origin so that it's coincident on this particular origin point. You can also add a dimension here and say make it a whole number, let us say 36, and you can say okay. And once you have made that particular circle, the next stage is pretty simple. You can go into the model tab, and you can go to extrude, and you can say extrude up to surface, and you can choose this surface. So this way, when you hit merge, it is not going to form any extra lines, and the body is formed smooth and perfect. And lastly, we have to make these two holes. So you can select this particular face, make a mesh sketch on that face. I don't see any preview here, so I'm moving my offset slightly down. Okay, I see the internal hole clearly. So I can hide my mesh, make a best fit circle, and I can put this on the origin. And following this, you can add your dimension to this circle. So it's 21.99 mm. So I'm going to change it to 22 millimeters. And as you can see, the sketch has become fully constrained. So now I can come out, and I'm going to make a through hole. So I can go to the model tab, and I can use the extrude button, and I can do a mid-plane cut like this throughout this body. And instead of the merge, I can say cut to get that particular hole. And lastly, we have these two holes, so I can use the face of the solid for this as well. So I can pick the mesh, and I can hide my solid, show my mesh, and I can move it down a bit so that I see those two holes. And I can best fit circles by tracing on each of them. And I can select both of these circles, go to my constraints tool, and add an equal radius constraint. And I can add a dimension to these radii. So it's 11.89989. So I'll make it 12 mm. And I can say okay. And once you have completed this, you can come out, and you can go to the extrude tool in the model tab, and you can click on extrude. And since this is a through hole, I can use a mid plane, and I can say in the results operator, I'll cut it, and I'll say okay. So here we have learned how to align this particular body with respect to its own part coordinate system. And we have also seen how we can use the existing features and lines on the CAD, how we can use the convert entities tool to project those lines onto our plane and use it for accurately making our body and also making it smooth and continuous. And we see some red lines going here as a streak. So you can go here and select a fillet and ask the software to estimate the radius from the mesh. So I'm going to add 1 mm here, and I can pick these edges as needed and add my fillets. So I'm going to pick these edges, and you can say add the fillets here, and it is going to make our body look very nice and green. So you can add the fillets this way and say OK. And as you are completed with this particular model, you can add another fillet here. And this is 3.96 mm, so I can save it as 4 mm. And you can save this model. So you can save this by going into File, and you can say Save As, and you can save this in whichever folder, and you can save this as a machine underscore alignment exercise. And Geomagic files are saved as .xrl files. This is the format for the Geomagic DesignX file. Then you can open this file whenever as you need. And if you want to transfer to CAD, you can say transfer to CAD. You can open SolidWorks, and you can say go to next stage. Now, the software will open SolidWorks in the background, and it will attempt to recreate all the items that we have done in the Geomagic DesignX. As you can see, it's recreating all the extrudes, extruded cuts. It's also done the alignment. Everything falls right within place, and the body is completely exported. So here we have got the entire model history transferred from Solid DesignX into SolidWorks. An extrude comes as an extrude. It also contains the basic sketch along with the constraints that we made. The extrude object is transferred as an extrude body. You can roll back in time and check through the progress of this particular model step by step. So this is how you can align a scan to your local coordinate system and make use of features like convert entities and use the base planes themselves. By base planes, I mean the front, top, and right plane to make your CAD body. With this, we come to the close of the alignment lecture. Thank you.